Grade 10, Unit number 4 and 5, Force and Friction with Anas Mohideen. Force. What is called a force? Force we simply define as either a pull or a push. You can see here, force is given as a pull or a push. It could be demonstrated in a diagram like this. If you apply the force towards yourself, that is called a pull, and if you apply the force away from yourself, that is called a push. So this is a pull, and the second one, it is a push. Right. By applying this force, there are 5 changes, 5 effects can be seen, can be observed in objects. That is, by applying a force, the motion of an object can be stopped. If an object is moving, that motion of the object can be stopped. At the same time, by applying a force, the object at rest can be moved. An object at rest can be moved. And by applying a force, the speed of an object can be changed, either it could be increased or decreased. And by applying a force, the direction of an object can be changed. And also by applying a force, the shape of an object can be changed. So these are the 5 effects could be seen by applying a force over an object. But is that just because of force applied, an object will be moved? No. You can see the object given here, the diagram given here. A person is trying to push the table kept over a surface. Let's take the surface as the ground. So there are 2 contacting surfaces here. One is the table, the other one is the ground. Now the force applied by the person over the table is taken as the applied force here, and against this motion of the object, the first object, the table, there will be a resistive force applied by the second surface, that is the ground floor. So this is what we term as the frictional force. About the frictional forces later in detail we will be discussing. Anyhow, this frictional force is the resistive force against the motion of the force applied. Somewhat, when the person is increasing the force as to move it, there is a level where the friction cannot increase more than its maximum. At that time, even a small force, when you increase that at maximum level of frictional force, the object starts unbalanced and to move. At this time, what is the force applied? Now the force is termed as unbalanced force. So accordingly, by the unbalanced force only, the object will be moving. So there is a relationship between these three. What is the relationship? Unbalanced force is equal to force applied minus frictional force. For an example, let me say the force applied is 50 Newton and the frictional maximum force is 45 Newton. 15 Newton minus 45 Newton. It's just 5 Newton will be the unbalanced force, and that is the force that the object will be moving. There are 3 laws implemented by Sir Isaac Newton with regarding the motion of the object. So those laws are what we are going to take now. The first law of Newton regarding the motion we are going to take, that is, until an unbalanced force is acting on it, an object at rest remains stationary while an object in motion moves at uniform velocity. That means, look at the image given here. The object 1, it does have a velocity 0. That means it is at rest. Now, let's say if there is no any other forces have been applied, then the object remains at rest. It never moves. If there is a force applied and if it is sufficient to move it, then the object will be moved. So accordingly, that is the first part of Newton. Until an unbalanced force is applied on it, an object at rest remains rest. And the second object here, it's moving at v velocity. If there is no force applied, continuously it will be moving at uniform velocity. Let's say if there is a force applied in the same direction of motion, then the velocity will be increased. If it is in the opposite direction of motion, velocity will be decreased. So accordingly, the second part of the law, an object in motion moves at uniform velocity if there is no any unbalanced force applied. So this is the first law of Newton. Now we go for the So what is the second law of Newton says? Let's say the acceleration of an object is directly proportional to the force acting on it while it is inversely proportional for its mass. There is an object given here having the mass m. The force applied is capital F. Due to the force, the acceleration would be simple a. So in between these three factors there is a relationship given by the second law of Newton. It says that acceleration of this object will be directly proportional to the force. Direct proportion we take here as if the force is increased, acceleration will be increased. If the force is decreased, acceleration will be decreased. And the second part, acceleration is inversely proportional to mass. That means if the mass is increased, acceleration will be decreased. If the mass is decreased, acceleration will be increased. All three factors together now we can summarize in this way. Acceleration is directly proportional to F over m, force over mass. Now let me take force subjected here. Then it will be giving you force is directly proportional to m into a, mass into acceleration. So when we are doing this as an experiment several times, we could see always this m into a value will be the same, or else f over m value will be same. It will be giving you a constant value, but the aspect ratio should be correctly. So taking this aspect ratio as 1, we have formulated a law. What is the law here? Force equal mass into acceleration. That is capital F equals simple m into simple. Here the mass is always measured in kilograms. A is measured in ms minus 2 meters per square seconds. Accordingly, kg ms minus 2 is the unit. For this we are giving a specific name, that is Newton. Accordingly, the standard unit of measuring force is capital N Newton. The second law we have done. We are coming for the third law of Newton, Newton's third law. Every action has an equal and opposite reaction. Whatever the action you take, there will be an equal action and opposite. Every action has an equal and opposite reaction. Whatever the action you take, there will be an equal and opposite reaction. So it shows you there are two, right? Both the forces have been given as capital F, the same force, and they are acting against each other. So this is the third law of Newton. So accordingly, once again we are reminding with all three laws. That is, the first law of Newton says, until an unbalanced force is applied on it, an object at rest remains stationary, while an object in motion moves at uniform velocity. Second law of Newton says that acceleration of an object is directly proportional to the force applied on it, while it is inversely proportional to the mass. And the third law of Newton says that every action has an equal and opposite reaction. Equal in magnitude, opposite in direction. So is momentum. What is this momentum? Momentum is a measure of how difficult it is to stop the motion of a moving object. Right? How much it is difficult to stop the motion of a moving object, it is what the measure taken as momentum. But in physics we are giving a different definition. That is defined as the product of mass and velocity. Accordingly, here you see the object having the mass simple m, having the velocity v and the momentum p. So there is a relationship between these three factors too. It is said to be the momentum is directly proportional to mass. When the mass is increased, momentum will be increased, and vice versa. Same way, the momentum is directly proportional to velocity. When the velocity is increased, momentum will be increased, and vice versa. Both together we take it as now momentum is equal to mass into velocity. So P equals m into v. M is measured as kg kilograms, velocity is measured as ms minus 1 meters per second. Both together kg ms minus 1. Earlier in force we said that is kg ms minus 2, and here it is kg ms minus 1. And both force and momentum are said to be vector quantities because they do have a magnitude as well as a definite direction. The next topic is F equals ma using momentum of an object. So we are going to derive a common equation using both the formulas you have learned. That is, you see here, if the velocity of an object of mass simple m is increased from u to v during a time period of t because of the action of force F is equal to ma. That is the first formula that we are using here. F is equal to ma, but a is equal to final minus initial velocity divided by the time taken. Alright. So this final minus initial velocity dividing by the time taken, I am going to substitute at the place of a. Accordingly, F is equal to m into v minus u divided by t. When you multiply this, it gives you mv minus mu divided by t. And you know that momentum is equal to mass into velocity. So here the first part, it gives you m into v, final velocity. That means this mv should be the final momentum. As the same way, m into u, initial velocity, so it should be the initial momentum. Accordingly, we derive a relationship, a formula here, that is F equals final momentum Pf minus initial momentum Pi divided by the time taken, and this is a formula usually that we are using in questions in our exam papers, right? Next we are coming for the topic mass and weight. What is this mass? Most of the people, you do have a question, you do have a misconfusion between mass and weight. Mass means that is the amount of particles contained in an object, and weight means that is the force applied, simply that is the force applied over the object towards the earth due to gravity. Mass is what we measure in kilograms, whereas weight is measured in Newton since it is a force. So what is the relationship between? See here, if the mass of an object in free fall is taken as m, where g, gravity is the acceleration due to gravity, yes, then the force of gravity W is obtained by, the force of gravity is what we take as the weight. You see here, F equals ma, here to the second law of Newton we use. So look at the object here, the force applied down is W and the acceleration is g downwards. The mass is the same m, because wherever you take an object, unless if it is changed, if it is broken, the mass will not be changed. So accordingly, what is the force applied here? W, its weight. The mass is the same and the acceleration is gravity. So what is the relationship here? F equals ma, from that we are getting another relationship, that is W equals mg, means weight equals mass into gravitational acceleration. So this is what regarding mass and weight. Okay. Hope you did understand the theories of force in a simple way. So with that, we will go for the next topic. What is this friction? We have almost taken this word earlier, that is a resistive force. When there are two contacting surfaces closer to each other, they are contacting each other, and when one is tend to move in one direction, the second surface will be applying a force, a resistive force against the motion of the first surface in the opposite direction. So this is what we term as friction. So accordingly, the forces acting between two contacting surfaces which prevent or retard the relative motion are known as frictional forces. So what is the property that generating frictional force here, that is called friction? It could be demonstrated like this. You see, this is the pushing force over this object, and there are two surfaces you can see. Alright, the force is applied over the first object, and meanwhile in the opposite direction there is a resistive force applied by the second object. Okay, somewhat if the pushing force is exceeding than the frictional force, then the object will be moving in this direction. Alright, so this is what the basic fundamental theory about friction. And this friction applies in three ways. Accordingly, there are three types of friction. What are they? Static frictional force, limited frictional force, dynamic frictional force. So that is what we are going to take one by one. Static frictional force. So what is this static frictional force? You see here, there is an object kept on, and two surfaces are there. The force applied over the object, but the object is not moving. Still it is at rest. At this time, what is the friction applied over the object? That is called static frictional force. Simply, if an object is at rest, though there is a force applied, what is the frictional force acting over that object at this moment? That is called frictional force, static frictional force. Accordingly, the frictional force that acts when there is no relative motion, even though a force is applied on the body, that is called static frictional force. Static, by the term it says, it's at rest. Okay. Right. Now the second frictional force. Now, on the object, the force that you apply, you are going to increase. When you increase the force, frictional force will be also increased. But the maximum frictional force that acts on the body will not be exceeding than its maximum level. So up to that maximum level, the friction could be increased. Until that, the object will not be moving. Okay. Now let's say if you are increasing your force, meanwhile the friction is also increased. For an example, let's say 50 Newton is the maximum frictional force, you are also increasing up to 50 Newton now, right? Both becomes equal. That means still the object is at rest, it is balanced. Now let me say your force that you are going to increase here up to 55 Newton. From 50 you are going to increase up to 55 Newton. Means you are increasing your force 5 Newton than the frictional force. That becomes the unbalanced force. Correct? Okay. So you see now, let me take the earlier part. The maximum friction that is applied when the object is just begins to move. It's not moving, right? It is just beginning to move. We can see it's gonna be moved now. At this point, what is the friction applied? That is called static frictional force. Okay. That is called limiting frictional force. Accordingly, the maximum frictional force that acts on a body as it just begins to move is called limiting frictional force. Dynamic frictional force. We come step by step. Static frictional force, we said the object was at rest. Limited frictional force, we said that becomes the maximum friction, the object just begin to move. Now you increase the force more and more, we could see now the object will be moving. So when the object is moving, you see here it does have a velocity v. When it's moving, what is the force applied now as the friction? That is called dynamic frictional force. It is in relative motion. Accordingly, the frictional force that acts on bodies when they are in relative motion is called dynamic frictional force. So we move to the next one. Factors affecting the frictional forces. Now, for the friction to apply over the objects, there are some factors affecting. Basically, there are two factors. The first one, perpendicular reaction force for the normal reaction. That means whatever the object you take, if it is having a mass, the matter does have a mass, right? There will be a force applied downwards. Let me take it as a weight. Alright. So if the weight is applied down at the same line of action, upward there will be a reaction. That is the normal reaction. Even when we are staying straight downwards to the ground, there will be our weight applied in the same line of action from our head upward. There will be a normal reaction, so we are balanced. Okay. So this perpendicular reaction force, how it will be affecting the frictional force. You see here A and B, two images have been compared. A, it is a heavy box. That means the mass is high. Mass high means force applying downwards will be high. That means the weight is high. If the weight is high, the normal reaction will be also the same, right? Every reaction has an equal and opposite reaction. So the force increased for a level downwards means the same level will be increased up to as the reaction. So accordingly, here the normal reaction is high since there is a heavy box. B, it gives you a light box. So the heaviness is less, the mass is lower, weight is lower than A. Now when the weight is lower in B than A, normal reaction will be also less than A. So accordingly, we can make the comparison. Normal reaction of A is more than B, so the frictional force acting on A is more than B. That is due to when the perpendicular reaction force or the normal reaction is increased, frictional force will be increased. Accordingly, A does have the higher friction, B is having the lower friction here. And the second point, nature of contacting surfaces. There are two types of surfaces we take. We are comparing each other: smooth surface, rough surface. Lower friction will be applied in smooth surfaces, whereas the high friction will be applied in rough surfaces. It is due to the roughness, the rough nature it does have, and due to this it will be giving a high resistive force against the motion of the object than in smooth surfaces. So accordingly, here you see A and B. A is having a smooth surface, so it should be having a lower friction. B is having a high friction due to it is having a rough surface. Okay, so let me take now roughness of the surface. A is less than B, so the frictional force acting in A should be less than B. So accordingly, these are the two factors affecting the frictional forces. The summary here: when the perpendicular reaction force or the normal reaction is increased, frictional force will be increased. When it is decreased, frictional force will be decreased. Same way, nature of contacting surfaces: when the roughness of the surface is increased, frictional force will be increased. When the roughness of the surface is decreased, friction will be decreased. That means smooth surfaces will be having a lower friction, rough surfaces will be having a high friction. Right? Factor which does not affect the frictional forces. So there is one factor which won't be affecting the frictional force, that is surface area. Surface area is different from contacting surfaces, the nature of the contacting surfaces, right? Here you see there is an object, it does have three surfaces. The three surfaces will be having three surface areas, A, B and C. You can see the difference. What I am going to do now, I am going to keep this object over a horizontal surface. First I am taking the surface A as the contacting surface area, and then you see that the first one A, and then B I am going to take as the contacting surface area, and then C I am going to take as the contacting surface area. Both these three instances I am going to pull the object using a Newton spring balance. I could see when it is just begin to move, when the object is just begin to move in all three instances, what is the force acting on the object will be equal in all three. That shows you that the force applied will be the same in the other side, the friction is also same. Accordingly, we can say that factor which does not affect the frictional forces is the surface area. So next we are coming for the advantages of frictional forces. There are many examples. So the first one we are taking here, we are walking on different surfaces, right? And we have been balanced without slipping down. That is due to, you see here, the force of reaction of the earth affecting the leg, the force of static friction between the leg and the earth. So you see now, when you apply the force in one direction as to move on in the opposite direction by the road over your leg, over your feet, there will be a force applied. That is the resistive force, and that becomes the frictional force here. So accordingly, actually here you take, there is a high friction applied due to the cuts, due to the grooves applied on your shoes or slippers. So this rough nature of the surface will be increasing the friction, so you won't be slipping down. Same the tires. These tires are also having cuts, also having grooves. Due to this, it is also having a rough structure, rough nature, rough surface, so it will be increasing the friction, so that this friction prevents tires from skidding off the road. Okay, and there are some more examples. Striking a matchstick, there are the rough surface here. So when you are striking, it will be generating a heat energy, so that there will be a lighting taken place. And spiked shoes of cricket players and football players or whatever, the players in athletics, so they will be having these spiked shoes because it gives you a rough surface. So due to that, they won't be skidding down, slipping down. And also we are able to drive automobiles, all those types of vehicles, as I said earlier, they will be giving you a high friction, so they won't be easily skidding off. Even writing on papers, there is also a friction applied. So these are the Now we come for disadvantages of frictional forces. What are the disadvantages? More force is required to drive. So due to these cuts and the rough surfaces, it won't be easily moving. So you have to increase the force. Actually, the pushing force should be increased and the driving force should be increased. So the force that you apply has to be increased. So that is one disadvantage too. And wear and tear of materials. So when you use these tires, the shoes, slippers and all for a long time, since the friction is high there, they will be wearing off. Even the rubber pads of these bicycle tubes and all, so they will be wearing off and sometimes they will be tearing too. So this is also a disadvantage. Causes noise pollution, that is also due to frictional forces, and causes fires in forests, that is also due to colliding of these materials. Okay, so these are some disadvantages of frictional forces. So overall, what happens here, heat energy and light energy will be wasted out. So energy loss is the disadvantage, simply to say, of frictional forces. So next, in our day-to-day life, we have to increase the friction and decrease the friction in different occasions. So how do we increase the friction? Almost we learned that there are two factors affecting the frictional forces. One is the contacting surface, the nature of the contacting surface, and the other one is the perpendicular reaction, normal reaction. So that is what we are going to apply here. You see here, in both these diagrams, the contacting surface nature has been changed. Actually, the roughness has been increased. So when the roughness is increased, friction will be increased, so that we won't be slipping, we won't be skidding easily. So the friction has been increased by increasing the roughness in different ways. And also cutting grooves. Cutting grooves also will be making the surface rough, it is not smooth. And the next part, you can see a chair or a furniture kept over the smooth tiles could be easily slipped on due to the smooth surface of the tiles. So what we do now, between those two contacting surfaces, an intermediate surface, a rough paper or rough sandpaper or any rough material we are keeping there as to increase the friction, so it won't be easily. So these are some ways of increasing the frictional force. And also, when you increase the mass over an object, for example, just imagine if you want to increase the friction over an object which was kept over these tiles, you can increase the mass of the objects kept over that furniture or whatever. If you increase that, the weight will be increased, the normal reaction will be increased, so it won't be easily moved. So simply to say, let me take a cupboard loaded with goods, you want to move it, you can't move it unless you remove some loads. Why is that? Because it does have a large amount of material, so it will be giving a higher mass, higher weight, the normal reaction is high. Once when you remove some goods, the mass will be decreasing, weight will be decreasing, accordingly normal reaction will be decreasing, so the friction will be decreasing, so you can easily move it. So these are some applications where we increase the frictional forces. So next we are coming for the advantages of frictional forces. There are many examples. So the first one we are taking here, we are walking on different surfaces, right? And we have been balanced without slipping down. That is due to, you see here, the force of reaction of the earth affecting the leg, the force of static friction between the leg and the earth. So you see now, when you apply the force in one direction as to move on in the opposite direction by the road over your leg, over your feet, there will be a force applied. That is the resistive force, and that becomes the frictional force here. So accordingly, actually here you take, there is a high friction applied due to the cuts, due to the grooves applied on your shoes or slippers. So this rough nature of the surface will be increasing the friction, so you won't be slipping down. Same way, when you take the vehicle, decrease the frictional forces, and that is about all frictional forces here. So we hope that you all understood about the theories of both friction and force. So under force we learn what is a force, what are the impacts of force, and what are the laws implemented by Sir Isaac Newton regarding that. The first law, second law, third law we learn, and equations as F equals ma, P equals mv, as well as mass and weight, W equals mg. And under friction, the concept of friction, the three types of friction: static frictional force, limited frictional force, dynamic frictional force, as well as what are the advantages and disadvantages, how to increase and decrease the frictional forces we have learned. So this is all about our lesson. This is the summary out of what you learned under force and friction. To get notified about our next videos, subscribe to our YouTube channel Science with Anas Mohideen.